And Dmytry Koробov will tell us something about the really interesting phases of archaeology, first millennium AD. Is that right?
Yes.
Yes.
Yes, of course we are talking all these 2 days about the early 21st century. And for me it is a very great honor to be here, but also a very difficult task to make this concluding paper on this wonderful conference after such a number of absolutely brilliant presentations that we were listening to these 2 days. And actually it is also very difficult for me because I am a practical archaeologist, not very theoretical. I'm concentrating on methods, maybe much more than on theory. But to be actually in fashion for this conference, I also prepared a couple of theoretical slides just to remind you that you know very well, and we were talking about this from the beginning, that the archaeology actually had dramatically changed from the second half of 19th century, when it was something like an antiquities and treasure huntings and very huge large-scale excavations just for recovering exciting architecture, to the real interesting half science, half humanities, like Sabina showed us, with rather precise methods, with a lot of technique. And I think between the humanities, the archaeology is the highest, maybe the deepest science with such great number of scientific application. That comes actually from the beginning, and we were talking today also, listening to Maria and Sabina, of course, yes, that from geology, from biology, from actually the first steps, archaeological steps, we applied different methods. Here there is just a general list of the sciences that we use in our investigations. That's archaeobotany, archaeozoology, aerial photography that comes from the beginning of 20th century, and palynology, soil studies, geophysics from 1930s. From the mid of 20th century, approximately 1950s, that is different analysis of metallography, spectral, of course radiocarbon, and so on and so on. So that is a really great, big list of the methods that we are applying. And just in the early 21st century, we have such large number of absolutely new toys, like Randall told in his wonderful presentation on the first day, and we are playing these toys on the very different levels. So if we are talking about the landscape level, we could play such nice new toy that appeared for topography only in around 2000. And in archaeology it started to be applied around 2005, 2006, there were some first publications, and now we could actually look under the forest. We could just remove the vegetation from the surface, and we could find absolutely new archaeological structures, like barrow groups, or like the traces of agriculture, or we could also use it for the very well-known sites like Birka, mentioned by Klaus. That is a wonderful image of LIDAR of Birka. That is also the first, actually, real imagination about the site that was obtained just maybe 5 years ago, maybe, I do not know, around 5 years ago. So now new methods, new techniques. Actually methods are old, but technique is very fast developing, and now in archaeological geophysics, they could use very fast tools, and they could cover several hectares per day with a very precise geophysical prospection. Like actually, I stole from Klaus a couple of slides that was made in Hedeby. He has already shown today. New tools of the 21st century, laser scanning, and especially photogrammetry. Laser scanning is a rather complicated technology that needs a real good specialist and a lot of technical equipment with a very high price. but just for last 5 years maybe, we got another new toy that is a rather cheap drones and not very expensive computer applications that give us a really good tool to create the 3D models of the sites, of the constructions, and actually of the artifacts too. We were talking today about the individual level, and thanks to Maria and Sabina, we were discussing the isotopes that could explain us the paleo diet and mobility, and of course paleo DNA is the most exciting theme now, and it is obvious that on the conference like this, the archaeology of the early 21st century, we should discuss all the time these paleo DNA studies. So I am also here, yes, with paleo DNA. Not discussed, just to say that there is a new tool on the individual level that we could have and we could use. We could go to the artifact level, and we have also new tools. It is not maybe of the early 21st century, because these first publications appeared in the beginning of 1990s. But anyhow, the widespread of these lipids analysis of the ceramic contains, it appears also in the early 21st century. Of course, there are new possibilities to know about the chemical contents of the artifacts, and thanks to our specialists also from our institute that are sitting here, we could analyze very precise the material by means of X-ray, fluorescence analysis, radiography, tomography, and so on and so on. So we have a number of tools, a number of toys, and we could apply it in our different approaches. One of them is very well known in the West, that is the landscape archaeology, came from, in England, I suppose it was late 70s, 1970s, beginning of 1980s. In Germany it was even earlier, in end of 1960s, in early 1970s, Landschaftsarchäologie. That is a real multidisciplinary approach that combines a lot of methods, a lot of different techniques to reconstruct the ways in which people in the past constructed and used the environment around them. So there are plenty of books in the West. Here in Russia, we are not so familiar with this approach, to be honest. There are not a lot of people who are making landscape archaeology. But fortunately, there are some of them sitting here, like Nikolai Makarov, who showed you these wonderful results in Suzdalapolia with the same, actually, approach, with the same methods. And me, one of them, and I'm very lucky to work in a wonderful region situated, yes, in the central part of the Ciscaucasian sub-mountains, in 70 kilometers to the north from the highest point of Europe, the Mount of Elbrus, that is visible on the horizon. We sometimes have this nice view if we are lucky. But we are lucky not only with these wonderful landscapes, but also with the archaeology. This rather small territory, something like 40 to 20 kilometers, is really full of archaeology, and it was investigated for last 150 years. And that is why in the mid of 1990s, the special project started in our institute to create the first archaeological GIS, to combine this data to put it onto the map. And when we start our survey there, to the end of 20th century, actually, to around 2000, we doubled the quantity of sites. And now we have around 900 archaeological sites on this small territory, dated from Neolithic period to the modern time. And now we could play with this data, we could actually analyze it, and we could look to the landscapes and trying to find some interesting details of the history of these sites. So our methods are rather routine and very well known. It is nothing special, of course. It's analysis of aerial images and space shots, field survey with collecting of surface material, making some test excavations and trenches. Sometimes we are making geophysical prospection, not we are making, we have good connections with German geophysicists who are making this for us, thanks to them. But we have a very deep connection and very deep cooperation with the specialists of soil science, especially Alexander Borisov from Pushchina Institute, who is a really good developer of new techniques and methods. And actually now in this presentation I would like to show you just a couple of these new methods that could help us to deal with the landscape archaeology now. This data is combined, analyzed by means of GIS analysis. So one of the big advantages of this territory is the preservation of landscapes. We are very lucky that there was no intensive agriculture not only in 20th century but also in 19th and even in 18th. We have totally preserved landscapes with a lot of traces of agricultural plots here. That is like a national reserve place. So for several seasons, many seasons, we were dealing with these traces of agriculture. We made more than 200 trenches and around 40 cores. We have collected almost 4,000 pottery sherds from our test trenches. Now we could analyze this data and try to reconstruct the stages of this agriculture. That is just one example how we were making these soil trenches inside these large, huge terraces. Some of the trenches were up to 4.5 meters depth, full of ceramic data. So we have calculated that from 1 cubic meter, we have almost 1 kilo of ceramic in these fields. That is really huge number of data that could be analyzed. And because of this ceramic now, we could reconstruct the main stages that could be broadly shown as the agriculture of late Bronze Age, early Iron Age connected with the large, huge terraces, perhaps created by means of matting. We have a real Celtic fields here with the rectangular plots with the visible borders made by crisscross plowing. Perhaps we do not have these traces of these plowshares, but obviously it should be like this technique. And because of ceramic finds inside these fields, we could connect it with the Alanic culture of the early Middle Ages, Merovingian period in European sense of view. And we also have strip lynches, very nice fields, quite a lot of them, up to 400 meters long, yeah, around 6 meters width and up to 1 meter high. That was obviously created by means of heavy plowing, and it could be connected with the High Middle Ages. So now we are trying to make some more precise investigation, and we are trying to find the traces of manuring on these fields. So our task is to prove that some of these areas were fertilized by means of animal dung. When we are talking about animal dung, we have this old paradigm came from the 20th century that animal dung could be indicated by means of ceramic sherds in the fields and by means of phosphate contents. So that is the simplest and the most widespread methods to recognize the traces of manuring in the ancient fields. But these indicators, they are lovely, but also have some disadvantages because they could be connected with the manuring and could be not connected. They could be connected with any human activity inside the settlement, outside the settlement. We could find ceramic sherds, we could find this phosphate content. We are trying to make new indicators, and our specialists in soil studies, they actually found these two new toys of the early 21st century. The advantages of these both methods, that they are rather simple, they are very cheap. We do not need a very complicated equipment like for paleo-DNA analysis or isotopic or something like this. And they are very fast, so we could make some of these procedures in the field, and it costs not a lot. That is urease activity. Actually, it is the calculation of quantity of urine inside the soil, and this urine could be preserved for centuries, even for thousands of years. And another very nice indicator, that is a thermophilic microorganisms, thermophilic bacteria, that are also situated in the soil for centuries, and if they have a right temperature, between 60 and 70 degrees, they started exploring very fast in a very large quantity, and we could prove that this place was with the animal dung, because there is practically no situation in pure nature with the temperature of soil between 60 and 70 degrees. It is obviously something connected with the manure. So using these two toys and others, we should actually first try to prove this idea, and we started to investigate the places of the livestock keeping. We are also very lucky in this case, because around Kislovodsk we have something like 1,000 stone corrals survived from different periods, and at least half of them were in use not only in the modern time, but also in previous. We made small excavations in a dozen of them, and we have practically everywhere found ceramic of early Middle Ages, and it seems that some of them, at least large part of them, was created at least at that time in the first millennium AD. Some of them were even older. But anyhow, inside these stone corrals that obviously were actually devoted to keeping the livestock, the animals, we could find these lovely indicators. Everything actually. Ceramic shards, phosphate content, urease activity, and thermophilic microorganisms that are quite large inside the corals and practically nothing outside. So it works rather good with these places for animals. We are trying to use these indicators in the fields, and we made several trenches on the different distance from two early medieval settlements, and we could find a very nice correlation between the quantity of ceramic, quantity of phosphates, urease, microorganisms that are in a large quantity near the settlement and reducing gradually with the distance of it. Now we could make a very nice reconstruction. You can see that there are some parts with the intensive manuring, with the distance up to 500 meters, less intensive up to 1,000 meters, and practically nothing outside. You can see that this idea fits absolutely perfect with the very old paradigm of Edward Higgs and his site catchment analysis that was published exactly 50 years ago. So it was made in 1969, these first publications about this analysis. But this reconstruction was made on the base of just several test pits. You can see just 5 of them, 2, 3, and so on, not so many. So last year we would like to make an extensive off-site archaeology in the Kislovodsk basin, and we started from the topographic model of the territory around 1 square kilometer using these lovely toys. And good specialists in this topography made a very nice model for us with the space resolution of 5 centimeters. And you can see the borders of the fields that are perfectly visible because of this technique with this 3D modeling. And we could put 100 test pits that we made last autumn near this place. And these test pits was done with the 10 centimeter layers. We actually collected ceramic, and we have collected almost 100 kilos of soil samples that was actually transferred to Pushchino, to this institute, to make all this analysis from every 10 centimeter. So now, if we try, yes, we have found more than 2,000 ceramic shards inside that actually could be divided practically in two parts, more or less equal, belong to this late Bronze Age or Iron Age, Coban culture that Sabina likes very much, and to my Alanic culture of the early Middle Ages. So we could share this data with you, Sabina. And now we could put it into the GIS and we could see how this ceramic is distributed, not only with the distance, but with the depth also. And it is a very different picture with the distribution that we can see here. Some of its early medieval, actually, it is a traces of agriculture from this settlement, and Coban period, they have another reasons for this distribution. Next work that was already done, it is the magnetic susceptibility and also phosphate contents that also has a very nice picture with this different distribution of the samples in depth and in distance. So we are actually also in the beginning of the new interesting parts of analysis. I hope that we could get new data with these new indicators. We will see. But anyhow, from my point of view, these new methods fits very good with these old paradigms, and we could use this archaeology of the 20th century in the early 21st. Thank you so much.
Thank you very much, Dima. So ADNA is not all.
Yes.
Okay. Please.
Yeah. Thank you for a very interesting presentation, Dima. I have a couple of very quick questions. The first is that, sorry, but I think I know something, and I couldn't catch. What is the chronology of the manuring graphics that you were addressing?
Yes, that's a big question, but we could actually reconstruct this chronology according to the ceramic shards that we have found. Of course, not very precise, but broadly, at least to the cultural periods. So it means that we could date it in frameworks of several centuries. I can't date it more precise because we do not have this precise chronology for ceramic.
But actually, when are you considering that they start? What did you?
We could prove that there was a practice of manuring in this late Bronze Age or Iron Age period. At least it was the starting point. And then it was also made in the early medieval period, but it was a chronological gap in between. It was not a process, so this evolutionary process, yes. It was a gap in between anyhow. But this gap was connected with some other reasons, and we know about this gap. Yeah.
The other question I had for you is that I see that the techniques that you are using to reconstruct, to identify manuring tactics, in a sense are quite reliable. However, they are still very unreliable techniques. So in a sense, it's, at least if you come to my country, and you try to use this sort of techniques to identify manuring practice, you could see that finally the results are not fully confident because they are underlay techniques. So my question is, are you trying some other sort of technique based, for instance, in chemical analysis of the old soils or whatever that could identify?
Of course, they are making chemical analysis, not only these indicators.
Yeah.
A number of analyses, yes. And in this case, we have this phosphate content also. But there is a very interesting point that is now developing by this team of the soil specialists. They are trying to divide the phosphates into organic phosphates and pyrogenic phosphates. Because we have a lot of phosphate content, not only because of organic. if we have a fire on the place, we also will have a lot of phosphates. But these phosphates have different origin, and now we could divide it.
Okay. Maria?
What about pyrogenic phosphate, the generation of this fire? Do you know about this fire? What does it mean? Some artificial or nature?
It could be artificial, it could be nature, it doesn't matter. If you have some organic material that was burned, you will have these phosphates, but it was a little bit different comparing with the pure organic, without fire. Yeah. We would test it also, such kind of evidences on the different contexts that obviously have these ash layers and so on. But it doesn't connect with these arable fields. It's another areas. Yeah.
Louder. Louder. Power.
Oh, okay. Is the new planography methods used in one region, for example, in the Stavropolsky region, as far as I understood, or it is the practice? It has its practice on another territories of Russia, and maybe you have a deal with another cultures. Is there any results?
We can use GIS everywhere if we have the data with these coordinates, yes, in space. So we have a national scale GIS, we have a lot of regional GISs, we have some GISs connected with one site, and so on. So in our case, we have this micro-regional, how to say it, yes. And it's not only Stavropol region, it is also Republic of Karacháyevo-Cherkessia, and so on. Yeah.
Could we go back to one of your very first slides with the map? Could we see that?
Yeah, we will try.
Isn't that
To the second or the third? At the very beginning of the Kislovodsk area.
Yeah, this one.
Yes, one more. And with the points.
Yeah.
And could you explain to us what the
Blue and red,
no,
yes,
no,
yes.
The blue dots in the north.
Blue
dots in the north, this one.
Ah, you mean this one?
Yes.
Yeah, I have already shown you in Budapest this data. Yes, yes, that's a lovely line of a very small fortification that was used for actually protecting the land and transferring the signals. And it was something like a small observation points. We proved it by means of Vyush analysis, and we made a special experiment of transfer the smoke signal. It was 15 years ago, and Sabina took part and was one of the organizers of this experiment. And it was, yes, very, very nice. Now I think that it belonged to the 3rd, 4th centuries AD and connected with the early stage of Alanic culture. That is the first traces of the Alans in the Kislovodsk Basin.
Okay, thank you very much. Now you understand why first millennium is so interesting. So,
thank you.
Okay.
Thank you, Klaus.
If there are no questions anymore, then I would like to hand over. Thank you very much, Dima. And now